So first of all, for the benefit of everyone else, Matt, do you want to give a quick introduction to what MAAS is and why people would use it? Just very quick.
So MAAS is a way to primarily to deploy Juju charms directly to bare metal. That's the main thing. So it allows you to basically abstract away all the details of a server or a group of servers and treat them just as you would a virtual machine. So you spin it up, deploy something to it, you don't care about the details of the machine really, although you can. And you tear things down, it's gone, and you're able to use the machine against something else. The canonical example being deploying an OpenStack cloud, which went down from 0 to having a fully operational OpenStack cloud in about 11 minutes and 30 seconds, which is quite astounding really.
So this session is where we plan where to go from here in this cycle and what we expect MAAS to deliver. Come on. So extra architectures. I think it's only natural that we would have to support ARM as well. It's clearly an emerging server technology we saw from Monday's keynote. So I think ARM's quite important. The other day, Julian was speaking about dropping cobbler. I don't know if people who are on the MAAS devel list followed that. This really ties into a lot of things. It seems that the reason to drop cobbler makes sense. We want MAAS to be able to go to hyperscale sort of levels, and I don't think we're going to achieve that using cobbler. We've hit many concurrency issues and other problems, so it's probably something we should do earlier rather than later. So that ties nicely to the ARM support. So dropping cobbler is something which looks pretty like it's going to happen, right?
Yeah. So are you dropping cobbler with or replacing cobbler with something else or something else?
So we currently use only like 5% of cobbler, so we're gonna re-implement the part that we use.
Which part of it? Is it just the TFTP?
Yeah.
I mean, we are not. Just for those who might have a confusion, we are not dropping cobbler from the archives itself. We are gonna stop using.
I know that.
We ship MAAS provision, which will be replaced.
Okay.
So you're only using part of cobbler functionality inside MAAS?
Yes.
Well, it has a lot of functionality that we don't use. We basically use it Pixie boot to install that.
We use it as an abstraction layer to create the TFTP files, and also as an index to manage the images, and that's really it, really, isn't it?
And the PC.
So MAAS will depend on cobbler?
Sorry?
MAAS will depend on cobbler?
MAAS currently depends on cobbler, but we're looking to remove cobbler as a dependency.
So, jumping back, when you say ARM support, one of the issues in ARM is that there are a bunch of different ways of booting it. Is there a focus on that ARM support?
Good, that's a very good question. MAAS at the moment is obviously architecture aware. It supports i386 and AMD64. You know, pretty much everything everyone needs. But ARM, by speaking I think to yourself in the corridor, ARM has too many variants. They haven't standardized, right? Which means that we're going to have like ARM HF dash Calzata or something.
Well, I actually have been taking a look on what it would take to port MAAS to ARM, and it's fairly complicated. So currently we've got three platforms that can. And I Pixie boot, and I put Pixie in quotes here because it's something that resembles Pixie, but isn't.
U-boot's implementation of Pixie Linux, right?
Well,
right.
Michael.
Yeah.
But regarding, besides U-boot support with PXC, is there any other thing that is kind of architecture related regarding the, we have
yes,
the booting and such, but that's type related with the desktop installer still, so.
There's things that MAAS will have to handle in addition to NetBoot.
Such as?
So, I did dive into the current of the internals, but do understand that I haven't had time to look extensively. Each, in addition to sub-architecture support, which is what you were talking about, the ARMHF-something, each board usually has a bit of unique quirks In addition, you need a set of packages that handle all the ARM. So you have the concept ARM HF, and then each platform has additional packages that layer on top of that. So the way the MAAS import ISOs need to be made a little smarter for ARM. In addition, we don't have ISO images, period, for ARM at all. Now we could build them, but you can't actually use them to boot because
So we just need to replace MAAS import ISO with something that downloads the UID and U image from the archive.
Well, I also saw
Is there anything else that we need to do apart from that?
Well, yes, but I also saw MAAS, looking through it, also downloads a core ISO.
Well,
it extracts the kernel and the initial ramblers. That's really a workaround for how cobbler works. So when cobbler's dropped and it's replaced by MAAS doing it itself, that ISO is
there was additional steps in there to set up a local archive because I watched it run in debug.
Oh no, what that is for the there's an additional ephemeral commissioning environment, and that downloads a cloud image, which is modified to have a generic kernel rather than the virtual kernel, and that's for running arbitrary code. But to actually get the operating system onto the machine,
oh, it does not use that.
We would still, I think, want a commissioning environment, but that would have to be special cased for our ARM.
It would have to be, yeah, it has to be special case for each sub-architecture.
The thing is, for example, if we had PXE with netboot support, like with that installer, it would be enough, I guess.
It should.
Yeah, it should be
But
enough.
that's something that we want to have anyway. So, and if we need any PXE support, I know that we are working on a Bennett support, and if you want to. Like Beagle support as well, and we have support for the others. It's just a matter of testing and make sure that it works properly. But once we have all the queries for all the sub-architectures in place, that's something that it's not only server related. Then we can have the next installed, and I think it should probably be all. Unless the PXE implementation at the U-boot is not enough, but that is also going to affect Calzeta as well. So
well, so
it is a little bit short. The cobbler and Anaric. When it falls to the default, the U-boot PXE boot implementation can't cope. It doesn't understand menus or something, the particular format being used.
More specifically, it doesn't actually implement the pre-execution environment part of PXE. It kicks directly into a kernel.
And stuff like chain.c32 needs an ARM equivalent as well.
Right, it's definitely not completely perfect. I did sit down with the MAAS enlist and ran it manually, and I got that to semi-work right up until I corrupted my environment. So once MAAS is set and installed, it should more or less be platform independent. It's just getting to that point.
Yeah, but that's a very good point Robbie raises, is something that we do with MAAS at the moment, is we support, once the operating system is installed, it then continues to PXE boot, but goes to local boot, so it gives a local configuration back. And
so that's a request I've made of the vendors privately, and they're aware that we need that kind of support.
There is some functionality. So U-boot has, so let's step back away. U-boot's netboot implementation really cannot be called PXE for these purposes. So, but U-boot has a pretty advanced scripting language built in that we have abused into a functioning bootloader. In addition, they have standalone apps which can run in the U-boot environment. It's pretty close to what you'd expect to see from PXE, although the APIs are somewhat limited. So there is some some area we can work. There is an environment that can be built in. The other problem is that some of the boards, specifically the Armadas, their U-boots are practically ancient, and they're not going to get updated anytime soon to something a little more recent. So it's quite possible that multiple forks will have to be handled once we can get all the vendors onto a U-boot that is from this decade.
Oh, but that's a minimal requirement. I mean, there's nothing we can do if the vendor doesn't provide an up-to-date U-boot. Then I mean,
I've spoken to the vendors about what requirements in terms of system management MAAS will require, and it's on the way. They're aware that it's not going to work unless those things are there. So I think in terms of developing MAAS, we can assume that system management is going to be in place. and not worry about the current version of Ubuntu. That can't be expected to be supported by MAAS.
Yeah, I don't think we can really write for hardware, which is, if you said yourself, this decade, you know, probably an exaggeration, but yeah, I think we need to be focusing on current technologies rather than...
Well, these are current technologies, but these are forks of the bootloader that they made 5 years ago and developed completely separately.
Right, but are they actually making server-grade hardware?
Yes, this is the Armada platform. Calzada is on a modern one, but there are things I can't talk about publicly, but there are platforms that I'm expecting to see with these dated U-boots that will be server grade. In addition, upgrading the bootloader on ARM on some platforms can very well brick it if it's done wrong, so it's something to be avoided if possible.
But still, that's vendor specific. Like, if they want to support UF5 or newer U-boot, like, they're fine to do it.
Yeah. So MAAS will require, for working on ARM, MAAS will require ARM servers to have a certain baseline support for system management.
Yeah.
If they don't have that certain baseline support for system management, MAAS will not support it.
Yeah,
if vendors want their hardware to work with MAAS, they need to get in touch with me, I'm Robbie, get in touch with your canonical contact, and we will explain what you need to do to make that happen. For the purpose of this discussion today and how we're going to work on MAAS, we're just going to assume that the baseline is already there.
Yeah, I agree.
One final point I just want to throw out there. Currently, MAAS is using Wake on LAN, not supported at all on ARM.
Yeah,
IPMI will be in
okay.
queue, I believe. Right there.
Yes, yeah, that's a firm requirement.
Who's just speaking back there? I just can't.
It's Robbie Basic.
Oh, Robbie Basic. Okay.
Yeah. Okay.
Did you say that we would support other VMC eventually?
Well, I think if we target IPMI, so I thought we were going to support IPMI and ILO, but I've been reliably informed recently that any ILO machine also supports IPMI. So IPMI is supported across the board, whereas ILO is obviously HP servers only. So, I mean, it's something we can extend, right? But I think for this release, if we just focus strictly to IPMI, then we get the best coverage across all servers.
But I believe that there is a pretty extensive power management library available from NUT. Should that be something we should consider rather than the specific implementation?
Well,
Nutman isn't here, is he?
No, he's not.
Well, it does have an extensive library. NAT has different has a different purpose than the one we require. The one we require is basically being able to start and stop nodes on demand. While NAT, its main purpose is allow machines to monitor the status of the UPS battery pretty much in order for them to shut down cleanly or not in case of a power disaster. Technically, we would also be able to use its library to do what we want, which is start and stop nodes, but that might be way too complicated for the use case.
Yeah, so does not give us any benefit over just using fence agents directly?
Exactly.
I'm sorry, but I'm hearing this as if you were telling me we are going to be addressing KVM directly and not through Limbert.
No. Hang on.
Let me finish, because what I'm seeing from when I look at the NUT project is a library that allows me from one point to address PDUs, IPMI, and specific vendors of whatever power management you need.
Yeah. So to use your own example, if I was addressing KVM, I'd be using an IPMI tool. Yeah. Whereas what Andreas just said was use fence agents, which is an abstraction layer similar to libvirt. But I mean, from what Andreas' investigation seems to include, was that NUT is actually more like VMware Server, if you like. It's a whole thing that sits on top of it.
But it's not modularized enough.
No, it's not that. It just does a hell of a lot more that
we actually
is out of
require.
scope.
Yes.
It's like using cobbler for MAAS. That's what I'm hearing anyway.
Yeah, you would say so.
Because cobbler does so much more.
Exactly.
But we don't want to use its persistent database and so forth.
I mean, I think that maybe if they would like to integrate this with MAAS and provide us an interface in order to be able to start and stop nodes in an easy way without from a central NAT server point of view, then I guess we could accept that. But from our particular view, I think we much rather continue with the usage of IPMI directly and maybe even sense agents directly, because it's a faster way for us to address that and much less complicated.
So when you use IPMI, is the only thing you're going to be doing power management, or are you also going to be doing stuff like
do boot management?
Yeah, boot management. Is that included in there as well? And is that planned for Q?
Does the ARM implementation support boot ordering?
I've requested it to be. I've yet to see what it will be.
That would be interesting.
And that's kind of why I'm asking the question.
On the Armada platform, boot ordering is theoretically possible. We don't.
Yeah, but it doesn't do IPMI, so it's out of scope.
Okay, sorry, I missed that bit of that.
It would be nice, but it's not necessary. I mean, as long as you can pixie boot and fall back to disk, I know that it's going to be an issue in power, but...
So you're going to be assuming that all your machines pixie boot and are capable of a local boot or chain C.
So the issues obviously with that model is it doesn't lend itself to hyperscale very easily, right?
Well, it's not that bad, but the issue I would think with it is that you cannot detach the provisioning network entirely, then, because it has to be there for boot. So
even then, once the machines are up and running,
you want to detach that thing entirely, and then if you can go muck with the IPMI, that's better. But so it's a better way to do it. But
so is that a goal that we want to be able to do for Q?
I think it's a medium priority, I would say. What do you think? The ARM stuff might escalate it really, because if we can't have a connect to chain.c32, then it's a good workaround.
If it's it's a better solution for that. So yeah.
So I asked one of our vendors came back to me and said, I can't actually remember which one, and said I got the impression that they're saying we can't currently do it, but a workaround would be to change the. What's it they said? To rather than using chain C32, to change the persistent boot configuration over IPMI to boot locally on the TFTP request.
Yeah.
So then the next question is, are we going to, I know it's really horrible to do it that way, so I'm going to try and push to make that not happen, but are we going to be responding dynamically to TFTP requests so that we could hook that?
So that's a very good question, because an idea we were bouncing around a while ago was, rather than using TFTP HPA as a TFTPD, did that make sense?
Yeah.
We were thinking about the sort of CGI model TFTP server, and
I prefer that.
The difference exactly?
You what, sorry?
What's the difference exactly? What do you?
Well, at the moment we're running, we're serving static content.
Right.
Cobbler generates the stuff to the disk, and we serve that over TFTP.
Yeah.
But one idea we were discussing was using a sort of CGI TFTP, where it basically generates on the fly.
On the fly.
Which may well scale better as well, because you don't.
Of course, to the box, it's not going to matter. It's all on our side. We've got to figure that out.
But the dynamic capability would be handy for any ARM-related hacks that we need to put in.
I think that's probably would solve some of the concurrency issues as well. I think, because at the moment, pserv has to say update this file, update this file, update this file, and basically stack them up. Whereas if it's just done on the fly, then I think it's do you agree with that? Or?
Yeah, it seems sensible. I mean, for the hyperscale stuff, to do it that way dynamically.
Okay, shall we move on? So something which I think we would really like to do was the actual initial commissioning environment. One of the ideas that was going around that was to do some benchmarking and basically generate some sort of data to see how how good the machine is, and basically whether it's going to fulfil requirements for what people want to use with it. And I'd really like to sort of have some ideas from the room on what tools we should use for benchmarking.
What are we benchmarking?
The whole shebang.
MAAS.
Time.
No, I mean sort of disk I/O, perhaps even network I/O. That one's a bit more.
So is this in terms of MAAS's operation or what the metal?
No, so basically this is what it puts onto the metal, or rather it's a iSCSI based network root file system where basically we can run the series of tests and post it back to the MAAS server.
For reporting purposes.
Exactly.
Right, okay.
So
Yeah.
is that like a qualification test? I'm not seeing your use case.
So
Yeah.
There's two purposes. There's one that is we need to know what the machine is good for. Does it have a very efficient CPU or very efficient disk? And second purpose is to do burn-in. We know that 90% of the failure will occur in the first 2 hours of intensive use of a machine. We want to not commission a machine that is faulty.
So is this just a charm somebody's going to write? Is this a is this a part of MAAS or is this not a part of MAAS? Is kind of where my question is.
So at the moment it sits in a script that you put on the MAAS server, and it gets pulled over from Cloud Init. And I think that's probably the sort of model to continue, is basically just have a shell script which can be stacked to generate varying tests, I think.
Is something that you want to run just after install, or?
No, this is pre-install.
Like, yeah, I know, but I mean, if you're just checking it once, like, and taking a decision of that, like, based on the results, like, isn't that reliable in a way that you can trust on the first result that you get, or you should be running that frequently? I don't know, after the installer is done.
So do you think it should be run regularly, or do you think it should be something?
I think if it's just running it once, it might get the wrong data for you.
Really?
Depends on the tool. There are tools that are doing it, I mean, periodically automatically. So you run the stress, you leave the CPU unstressed, and it brings the stress up again. It takes hours. Can't say it's one test.
So, what's your reasoning for thinking that you'd get different data based on different runs?
I'm not sure. That could depend a little bit on. I don't know if it's, but it's on matching. It's not virtualizing. So yeah, it might be a good because otherwise, for example, it's visualized or something. It might be depending on something else.
So, I mean, if we can come up with rationale for that, it's basically just a state, and you can bump the machine back to the commissioning state where this stuff could be run, for example. So perhaps if we continue with just thinking that it's run once, but if there's sound justification for doing it between deployments,
yeah,
or between tenants or something.
Because, for example, if you want to check the network throughput, I mean, that's pretty unreliable.
Yeah. It's also hard, right? Because you need two machines.
Yeah.
Yeah. You'd also want to get a...
How long does it take to run?
The commissioning?
Yeah, the script, the burn-in script.
Well, currently it takes, what, 2 seconds? Because it doesn't actually do anything other than post-back hardware information.
Yeah, there is
So it's really efficient.
We need to define a target time frame, like 1 hour, 2 hour.
Our initial plan was to allow the administrators to choose how much burn-in to do. Okay. So we would, in our mock-ups we were talking about, 30 minutes an hour, 24 hours. But
I would think that is something that's going to be customized anyway, the things that are going to be run there, the tools that like people are going to want to run some other things there.
Well, if the idea is to trigger a failure in terms of, okay, this machine would fail if it were put to use in 2 days, it would fail soon, then it should only be run once. Otherwise, you are actually wearing the machine down over time. I mean, you are provoking failures artificially.
Yeah. Yeah, I can see that.
I'm thinking about the hard disks.
Well, if we're doing disk I/O and it's an SSD, we are taking life off it. Yeah, I can certainly appreciate that.
But you'd also want to be able to run it when you stick a new disk in. So you want to have that ability.
But in a hyperscale environment, you're not. We want to make as much of this as automated as possible. So a manual, running burn-in tests manually when it's server number 99,000 is kind of.
So we want to do something like bad blocks at the node level, right?
Yeah.
Okay. So,
I mean, what's people's favourite benchmarking tools?
Well, one of the standard ones, probably like Bonnie and
Do you want to capture that, Andreas? Yeah, Bonnie plus that one. Yeah.
BioBench.
Davey, a lot of these things are already in checkbox, and you also get a system profile running. I don't know if the certification team is here, but you might want to talk to them. Most of their tests are automated, and you can probably just put it in, so you don't have to recreate all this stuff.
That's a good idea. I don't think any of us could consider checkbox.
And auto tests should probably have a bunch of those as well, integrated by default.
But is checkbox a stress test?
Yeah, it has Bonnie in it, and then they have extensions to it, so you can. I mean, it's just a framework, so you can mix and match. And like what Scott said, I'm sure people are going to want to pull things in and out depending on what the system is and what they want to use it for.
And checkbox does run without X, right?
Correct.
Okay, then they also look into that. No, that's a good idea. Thank you.
And should we submit report back?
Well, the reports should certainly be sent back to MAAS.
But back to we have a central checkbox that
You don't have to send it anywhere. I mean, you can decide where you want to send it to, but I think if it wants to go to the MAAS tool or if it wants to go to
I don't think it should be outside the control of the MAAS department. Not automatically.
It should go back to MAAS, and if we want to make MAAS have the ability to submit it further, then that should be under the web interface in MAAS rather than anywhere else.
Yeah.
Okay, cool.
Does MAAS currently have the idea of a failed node after bring up?
Yes. There's a timeout, isn't there, at the moment?
Yeah.
Yeah, so basically it'll mark it as failed to commission if it basically goes AWOL.
Or during commissioning?
Yeah. If it dis-
After commissioning?
Well,
okay.
Well, we probably need to dig into exactly when it can fail, but yeah, there is a notion of a timeout at the very least.
Is the hardware profiling that's done at this stage currently enough to satisfy the needs of Juju and its machine constraints?
No.
And so we're going to extend that to cover that as well as burn-in?
Yeah, so currently what we're doing is we're running, in the commissioning environment, we're running LSHW and posting our XML output back to the MAAS server. That's as far as it goes. It's not actually consumed, it's just basically stored.
You run Factor perhaps?
Well, Factor's Ruby, right?
Yeah.
And I don't think we want to introduce Ruby to a minimal image.
Okay.
I think do we know the constraints that Juju's expecting of the provider right now? So CPU cores, memory, disk space, is there, what else is there?
Yeah, I only say Factor because it gives you exactly that information.
Right, but those three things could be easily worked out with a shell script or whatever.
It's just the edge cases.
Do we know what the constraints that Juju expects from the provider to satisfy? Is there a list of that anywhere? Or anyone from the Juju team here?
I think we mark that as a thing to look into. Unless there's anyone from Juju Core here. No.
Is LSHW enough for working on ARM?
No.
No.
So what do we do for ARM?
Yeah, that's it. Factor. Sorry to keep saying it. But essentially, it's like getting this information is full of edge cases, and so we either try and keep track of all the edge cases ourselves, or we use a tool which is supposed to keep track of the edge cases for us. What would it take to get Ruby into that minimal image?
It doesn't matter. It can have to get installed. The biggest thing is the memory. I guess getting it into the initial image wouldn't be that bad. And as it is right now, it's a overlay FS, so everything you have to get installed is costing you, is bringing you close to the tipping point where you can no longer do anything.
So basically, people can change the commissioning environment themselves, right? But I would like it if what we ship was basically code written in Python, Shell, or even Go. I mean, I would prefer one of them three, I think. Does everyone else agree with that?
Well, I think why can we not just pull anything from that's already packaged and in main? So we're not going to change that code?
Well, we can, but I mean, suddenly it's, I mean, yeah, I mean, we're now having Python and Ruby in there, right? It's like a 200 meg image.
Especially your image is going to affect your boot speed, and also you're going to end up running, depending on what your target is, if you start loading up a whole bunch of other things with overlay FS, you could run out of RAM real fast.
Well, I don't know. I mean, these are pretty powerful machines.
Well, I'm thinking about like the you know, if someone has, you know, smaller arms and you're quite likely to be looking at 4 gig memory ceiling.
Can it be an NFS type thing, or an iSCSI image, perhaps? iSCSI read-only image?
That's a very good idea, because that's what it does.
Then it shouldn't be a problem how big it is.
Well, you have to modify. So right now, it's a read-only iSCSI image, and then it does overlay FS over it, right? So that we only have one iSCSI image on the server. Right?
So we do it to bootstrap. We apt-get install Factor.
You can install
and we
into
make that the image.
Yes, and I'm not really opposed to that. To me, it seems reasonable, and it doesn't really affect boot speed because that code doesn't get
it's just
until it's initialized.
The advantage is it takes away all the hackery that we need to do to get the hardware information on ARM.
The facts about ARM are nothing more than a switch saying this ARM and to...
Yeah, but there's only one place where that has to be maintained.
Right.
I don't want to add another one for MAAS.
Yeah,
I mean, there is a fork, or well, a rewrite of Factor written in Python, which I don't know whether it's still active, but it was a little bit crappy when it was underdeveloped when I last looked, and well, maybe that's something else we should look into.
Yeah, because I've already dealt with bugs in Factor in relation to ARM, and we're already dealing with getting those fixes uploaded.
What's your view, Adam?
It's Robbie's point versus do we want to deal with Ruby, but he's right, and I know the bugs you're talking about, so I was looking at fixing them, but I didn't have access to the hardware. So if you've already fixed them there and you've done the effort, I can see what.
Well, I'm just doing the testing for other people, but...
Yeah, no, I see what you're saying.
It's a bit of an effort to keep that maintained, and we're just doubling the effort if we do it using some other...
Just to be clear, Davey, your objection, your entire objection is that I don't like Ruby.
I'm not proposing that we undertake a coding project in Ruby, just that there is already a package there that we can use that gives us the information we need.
If you have other motivations, you should at least...
No, there's...
You can not say but
at least you're honest. I just don't like Ruby.
So if you want to if the landscape team want to maintain a Factor equivalent in Python, then we can use that.
No, that's not right.
This is silly. Let's move on.
I was going to say that we are interested in having LSHW working properly in ARM.
But how can...
The strange thing about LSHWs is such a low-level tool, it doesn't make sense. I mean, something like device tree, maybe. Access to the device tree blob might make sense, but LSHW is a very Intel-specific tool, given what it does. It's doing stuff like enumerating the PCI bus. Well, what happens if your soft doesn't have a PCI bus?
It doesn't enumerate, but it shouldn't crash with a sequence error.
Well, okay, it should just fail in saying, I can't find a PCI, but that doesn't tell you the hardware that's on it.
Memory, you can get disk.
So actually, it was mentioned that it crashed the other day, but Al Stone confirmed that it did exit 0. It didn't provide much data, it provided like 5 facts or so, if that, but it didn't crash.
On ARM?
I think he tried it on a different board, actually. Oh, an ARM board, but a different class. Yeah, but it wasn't Panda board anyway. So what you're saying, Scott, is we might be stuck with Factor, which...
I don't like the word stuck. I like the word Factor is an option that's already out there.
Yeah, I mean, the thing is one thing we really wanted to do with MAAS as well is make it so other tools could also make use of its hardware inventory and things and share data better.
So Factor is already kind of an accepted standard for the structure of that data.
More so than LSHW, is it?
Factor is more cross-platform than LSHW. LSHW is not entirely Intel specific, but it kind of expects like DMI to work. Does it use DMI?
Factor?
No, LSHW.
Yeah, yes, which is why you get nothing.
And there's no such thing as DMI on ARM, so it's just a little bit more specific. LSHW could be adapted to be made cross-platform, but Factor was already there.
So actually, Robbie, one of the really good things about Factor is it's very easy to write new facts.
Yeah.
And so basically, you get the core set, but you can also write Ruby fact generating to extend what it does, right? Which is probably really useful for our case, because LSHW might not provide exactly the information we need.
Yeah.
In fact, it can obviously enrich that.
So, I mean, I don't really like, personally, I can't stand writing code in Ruby.
Okay, so if you want to
rewrite, you have to.
If you want to rewrite it in Python,
I did a similar thing in Python at the beginning of last cycle. We were trying to do all this in the context of Orchestra, if you don't remember. And I don't know if I still have it, but it was an hour's worth of work to
that
come up with
sounds
something
much more
sensible.
supportable.
But he's right. It's going, and then it's going through and picking out the facts from Factor that we care about and porting those to Python. It's not a big project, but then we're at the point where we're maintaining something very similar to Factor in our own project. I don't know.
And admittedly, it's not that hard if there's a edge case that's added to Factor to port into Python, because you just look at the edge case and go, oh, yeah, okay, I can do that. Because it's really working out what the edge cases are and how to deal with them. This information in proxy view could be this string, in which case we need to do this.
David, can you capture?
It's that information that's tricky.
Yeah.
So it's not that hard. It's just that it's basically a fault and a fault code we have to maintain.
And the thing about Factor is these facts and things aren't what makes it valuable. It's how it hooks into Puppet and provides those facts to Puppet and configuration management that makes it a valuable tool. So it's its own framework. It's similar to the cobbler use case where we're only using a very small fraction of what it's actually designed to do.
Although Factor is nicely factored out from Puppet though, isn't it? It's a separate thing you can install separately.
Okay, we'll talk about this later.
Okay, so something else we were looking into to try to make the install a bit snappier was perhaps doing something like mimicking how the desktop installer works, and that's using a SquashFS based image to unpack that rather than the traditional DI model of unpacking and configuring each individual package. This would rapidly decrease the install time and perhaps provide something more solid as well, because we did hit some issues with having a proper archive we were installing from. Are there any concerns about doing that with ARM at all? Okay, Andreas, can you speak about, because you did a little bit of investigation into that, didn't you? Can you speak about how that's currently looking?
Well, basically, we pixie boot a mini image that we have, and then we tell through the AI to download the SquashFS image that we use, and then simply tell through the AI that we are using a live install image, and then the image just simply gets copied over the disk, and the whole process, everything else that the installer needs is preceded, but the only thing that basically changes is instead of installing things onto the disk, it just it just copies the image into the disk.
So you've replaced the bootstrap and the app setup part of DI?
We don't basically replace this. There's a package which is live installer that handles that.
It's a live install. It's a DI component, which we don't normally use.
Right. And that's to speed it up.
Yeah.
So, what if there's like a huge security hole like this SSH keys? How would that be updated to SquashFS?
Well, it would be largely the same as if you have an offline archive at the moment. I mean,
Would you have to spin it or?
well, you'll be able to get a new Squash FS image, or just install and and do an auto update on first boot.
When is Squash FS image generated? Is that dynamically on the MAAS?
That's done by the build, the CD image.
It would be generate an official Squash FS image.
Yeah,
it would.
MAAS
Yeah.
downloads.
And it'd be on the CD as well.
It'd be official Ubuntu, straight up live server CD.
And we would drop drop most of the packages on the on CD archive.
Can it be a DVD then?
Hmm?
Can it be like a DVD then?
What, for extra magic?
Yeah.
Yeah, but what?
Say if you want OpenStack, if you just want to install OpenStack.
So you're talking about the general server install, or specifically to MAAS, or both?
Both.
Both.
Oh, also, didn't really think this warranted a session, but we've been thinking about dropping the i386 big CD as well. But no one objects to it, and this room of people were interested in this stuff, right? Carried. Go on. Yeah.
Can I ask my question now? How would you deal with complex hardware configuration with Squash FS? Because I see that used for desktop installs with single disk, single network interface. Several environments is quite different.
Or don't you just set up your mount points and then copy it over?
I don't know, that's what I'm saying.
Sorry, can you explain the complexities again?
So, if I have a desktop image, which I image onto using this method onto a desktop, the desktop typically has one network interface, one disk, one processor, etc., etc. It's a simplistic environment compared to server.
You're causing trouble, James.
I'm sorry, but I'm saying we need to consider this. So, take the OpenStack type deployment. We need multiple network interfaces to compute those. How do we hook that configuration as a result of
It's a hard problem to generalise, right? I mean, do we just install to the first disk, or do we make some logical choices and make a RAID configuration based on the amount of disks which are in the box?
But you're still running Partman, aren't you?
Yes. So essentially, there wouldn't be any real difference of the path. The base set of packages would just be file system level copied to their target rather than package installed to their target. Yes. And then there's an additional set of packages that are possibly installed or reconfiguration. We're not throwing away. We're not suggesting to throw away the.
So this is an option of how to install your
You can do this for the.
It sounds like it's a copy based on after the mount structure's in place, is what you're saying.
It's a file system level copy. It's not block. It's not block level.
It's just replacing the point where to bootstrap and app setup.
Long term,
the network
block would
config
be
is still being done by DI beforehand.
long term block copy is more exciting because it's obviously faster than file copy.
Some people might disagree with that. Maybe.
Yeah.
So I'm not saying we need to answer this all now, but I think we need to keep that. Make sure that's long term.
Cool.
I think exactly the same issue we face now. So.
Yeah, I don't disagree. It's a problem now. It's a problem for this.
Okay, groovy. I really wanted to hear from Hugh regarding design changes. What your Hugh has been the person that's been driving a lot of the design of the MAAS web UI and things, and a key person that's chosen versions of web stuff which is too complicated for me. So Hugh, let's have a bit of a discussion about what you're planning, or what's been going on in your mind for this release.
So I think as MAAS ramps up, we're heading for more and more machines, and so the challenge of managing those machines becomes greater and getting the right level of feedback. So we want, and MAAS does not have to care too much about individual machines, but at times we really do have to care about individual machines. So so we've got to design an interface that allows you to do both of those things, and so there's going to have to be, we're going to have to work really hard on things like search for individual stuff and also grouping. So how I can get back a group of machines and do like,
actions.
Yeah, that's right, and do something like commission those through the web UI or whatever it is. So these are going to be some of the challenges. I think most of it is going to be surrounding that, and also looking at working on improving the status of your MAAS. So at the moment we have that chart on the front page and helping to visualize the state of the MAAS, not just I would dive into that a little bit more in detail. I don't have much better plans to talk about right now above that, unless there's something specific you want to talk about, because some of this stuff is really driving how that stuff might be implemented and how what information we might be able to get. So,
is there any more eye candy which is in your?
I don't have particular things planned yet, but once this stuff has been decided, I'm going to be able to have a look and see what things we can. Obviously, not all that stuff relates to eye candy, but
I think the most obvious thing would be live updates, live state, a live event and actions log on the front page or on user pages.
Well, maybe not on the front page, but on...
Well, I don't know, when we were speaking to Mark about it initially, he was quite keen to see
the action.
Right, so
a very high level.
Right, we want to be able to see what's going on in the MAAS, who's doing what, and also if we can, and I'm not sure where this is going to fit, I'd like to also see how we can get Juju status stuff into there as well. So not only seeing what your machines are doing, but what's running on those machines, and being able to get a bit of a health status of that, as well as visualize that somehow.
So are you saying that you want to plug TX Control everywhere? Because right now, the only page that gets updated live, I would say, is the dashboard. It's the only page that is really interactive in that sense.
Yep, so we're going to have to drive the interface being towards a more Ajax, JavaScript, long pole driven interface. Even we're going to work on how some of the forms, interactions with some of the forms are saved, and trying to, so we're going to have to rewrite some stuff in JavaScript so that we can have a more live updated kind of status stuff and
Okay. I got one question. Is there an API?
That's probably a question for Raphael.
What's that?
Is there an API so you can query like how many nodes or commissions and stuff like that?
Yeah, well, the basic API already does that. Yeah. I think
we do. Yeah, it does. You can list all. An admin can list all nodes.
Right.
And yeah.
Yeah, it does.
Yeah, we need a command line client. I think that's going to be there, but
it's going to be a tiny wrapper around the API.
Yeah, yeah. We need, but that, yeah. I mean,
some Blanco made a start on that last time.
Yeah, and then just dropped it. You guys are jerk. I would really though. I mean, just the little command line is massively useful to not require Juju in that.
Okay, I think we covered everything that was concerning me. So is there anything else? Is there anything else that people would like to raise? Question? Character shreds? Cool.
I can run MAAS without Juju, right?
Yeah.
Currently you can. I mean the primary the primary reason for MAAS is a Juju enabler for bare metal, really. Yeah, so currently you can, and speaking of the API tool, then yes, you can do that. But for the work we're putting into it, it's mainly to be a Juju enabler.
You can even, I think at this point in the UI, say deploy this.
Start node.
No, you can just start a node.
Okay, but I mean, like do an install.
I think we're removing.
That's right. Okay.
I think we're removing that, right?
I don't think it's been completely decided. I mean, like you said, MAAS is well, the main usage of MAAS is to be driven by Juju, and we decided to add this UI thing mostly for testing and to make the UI consistent in a way.
But also,
otherwise, it would be like just only user management and the cluster overview, but
the other reason for being able to start a node without Juju is the idea that not everyone's going to be ready to move everything to Juju, but we still might want them to feel they can use MAAS for those machines that they're not ready to use with Juju.
So if you remove that button, then it means that MAAS cannot be used by itself.
Well, if you have a command line UI, even if you don't have a command line UI, the API is generally easily enough to interact with. You can drive it elsewhere. But
so on ARM server today, when it arrives, we're going to want people to move their existing Intel stuff and run them on ARM. But on ARM, the provisioning is an install mechanism isn't clear. So if we couldn't get them to use MAAS to do that, it solves that problem. But they might well not want to charm everything. So because essentially there's a
that would be another barrier.
I mean, you don't have to charm everything. There's the Ubuntu charm. We just install Ubuntu and then you're done.
Through the web interface, if you could say, give me, so you've got this ARM cluster machine with 96 nodes.
I don't think we want to focus on that for the web interface actually. For API driven stuff, you could still basically use the EC2 model and provide cloud user data because MAAS has a metadata service as well, right? So I don't think we want to keep that in the basically the web UI. That's not really the sort of direction we're going in. So I think having it driven by an API is great, but I don't think we want to really do web UI.
So you're saying you're not going to have the API allow you to provision a single machine?
No, the API allows you, but not the web UI.
Okay, there's a quick question from someone in the channel about if we move to IPMI, will we still support?
I got an answer.
Oh, sorry.
I was doing the channel and I got an answer. Thanks.